So with this question, we're asked to express the resultant of the three forces here in terms of I and j. Now remember, I just quite simply represents a unit vector, okay, in the x direction. Okay, so what I mean by a unit vector, I literally mean 1, okay? So 1 in the x direction. And j represents a unit vector in the y direction. So that literally means 1 in the y direction. So in this case here, I've got 8 lots of I, if you think about it, yeah? Because we're not just going 1 unit in the x direction, we're going 8 units in the x direction. And we put I then to represent that, the fact that we are going this way, all right, in terms of the force. Now, with regards to the other two components then, well, these are going in the y direction, aren't they? So we've got 5 there, j, okay, going in the positive y direction. However, this is going in the negative direction, isn't it, in terms of the y-axis, so we can take away 7j there. So the resultant force, now we can call this anything, we can call it R if we want to, will be 8I minus 2j, okay, when you put them together. Remember as well, we need to underline the i's and j's and underline then these because they are vectors, okay. So part B then says calculate the magnitude of the resultant force. Now, quite simply, you just need to appreciate what our resultant force is. If you think about it, 8I minus 2j, well, that's like going across, isn't it, 8? Okay, because that's what it is, isn't it? And minus 2 means you're going down 2. Okay, so the overall effect is you end up here, yeah? You go across 8, down 2. Now, I don't have to write negative 2 there. Okay, the minus is only there to show that we are going down. But from my diagram, I've shown we're going down. So I don't need to write 2 there. But the resultant is we end up getting here from our starting point. Okay, so to work out the magnitude of the resultant force, I just want the size, if you want, the size of this line, yeah? That's effectively what we want there. To get the size of this line, we recognize this as Pythagoras, okay? So basically, to get the size of it, the magnitude of it, of a vector, what we do is we put bars around it, okay? Put bars around it, that just means that we're looking at the size of it, okay? The magnitude of it. Those two words mean the same, magnitude and size, the same meaning, okay? So we put bars around it for that. Now, in terms of how we do it, well, remember with Pythagoras, you square that, you square the other side as well, so you square the two smaller sides, add them together, yeah? So that squared, add that squared. And of course you square the third side as well, don't you? Because that squared plus that squared equals that squared. But then to work out your longer side here, you've got to take the square over and square root. You square root all of that there. So if I do that on my calculator, okay, I get the answer out to be 8.246 to 3 decimal places. So that is the resultant force there, okay. Part C then, it says draw a diagram to show the direction of the resultant force and find the angle that it makes with a unit vector I. So effectively, I've already done that here, okay? But the idea they want here is for you to appreciate where that resultant force is going. So, we could make it in terms of the x-axis and the y-axis, okay? And we've got the origin here, okay? And we just appreciate, well, we have gone across 8 to get to there, okay? And then we have gone down 2 to get to here, okay? So the resultant force will be taking you to there, okay? All right. Now we want the angle here that it creates with the I direction, yeah? Which is the x-axis. So that will be the same as that angle there, okay? And if you think about it, we could use, looking at this here, we could use SOHCAHTOA, and it's the tan one I always get to use it because if you think about it, opposite the angle there and the adjacent, those are the two sides I know. So tan theta is opposite over adjacent, so 2 over 8. So to get theta then, you do tan to the minus 1 of that. Okay, so on my calculator, we get out to be 14.0 degrees. Okay, and we're done.